Hello students, we welcome you to this session. In this session, we are going to learn about reduced instruction set computer. So, the full form of Risc is reduced instruction set computer. So, let's start Risc architecture. So, whenever a computer system is designed, its architecture is always considered first. So, computer architecture is the way with which hardware components of the computer can be connected to make a computer system. So, it also defines the structure of a digital computer. It also covers the design, layout of computer instruction and its storage registers. And in computer engineering, Risc is a type of microprocessor architecture that utilizes a small, highly optimized set of instructions. And Risc also provides high performance watt-wise for battery operated devices, devices that are battery based. Risc architecture is best for such devices. So Risc can perform million of instructions per second. So Risc can operate at higher speed. So in Risc architecture, instruction set of the computer is simplified. In this way, execution of time is reduced. And it has also a small set of instructions that are register to register operation based. Here, operations are always done from register to register. So, data is stored in processor register for computations, and the result of the computations are transferred to the memory, and for this store instructions are used. With store instructions, the results are transferred to the memory. So all operations are done within the registers of the CPU. In Risc, all instructions have simple register addressing because these use registers, and Risc uses a simple instruction format, and we can easily decode this simple instruction format, and the instruction length is fixed and can also be fixed, and it can execute one action in one instruction, and it can run one instruction per clock cycle. And by doing this, it optimizes the execution time for the operation. And this is done using pipelining. If you want to know much or more about pipelining, then we have already uploaded a video on pipelining, and please do watch that video for clearing this concept of pipelining. So for chip designers, Risc processor simplify the design process and provide a lower per chip cost because it uses smaller components. It needs smaller components. And because of the small instruction set and simple decoding logic, less chip space is used. And fewer transistors are needed and more general purpose registers can fit into the central processing unit. So, in this way, Risc architecture performs its task. So, in Risc approach, programmer will first write the load command to load the data in registers, and after loading, suitable operation will be done and the result of the operation will be stored at desired location. So in this way, add operation is divided into load, operate and store steps. So Risc computer, we have learnt about Risc computer. It has many high speed general purpose register and that are of load or store architecture, that follows load or store architecture, and which divides the instructions into two categories. The instructions are of two categories, maybe of one of the two categories. Number one, memory access instruction. Memory access instruction load and store data between memory and registers. And second type of instructions are ALU operation related instruction. ALU operations always occur between registers and execution of the Risc instructions are faster, and we have already learnt it takes 1 clock cycle per instruction. So Risc instructions are simple and are of fixed size. Risc instructions operate only on processor registers, and instructions that have arithmetic and logic operations should have their operand either in processor register, or we can directly mention the operand in the command. We clear it with an example. Here we have taken two statements, two instructions. In both instructions we have operands in registers. And in next instruction, green colored instruction, here we have directly mentioned the operand 100. Add R2, 100. Here we have directly mentioned the 100 operand. So operand can be mentioned directly. So we have understood two ways. So Risc processors are used in supercomputers, and processors that are based on this architecture are common in smartphones, tablets, laptops, gaming consoles and desktops, as well as a growing number of other intelligent devices. So that's all for this session. So we end our session here. Thank you. Have a nice time and keep on watching our channel, and please do subscribe our channel. Thank you. Bye bye and have a nice time.